You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech and Finding Genius Podcast Network. I have Stewart. He's the president, CFO, and co-founder of Ondas Networks, formerly Full Spectrum Incorporated, a wireless networking company that designs and manufactures its multi-patented software-defined radio platform for mission-critical IoT applications. And we'll get into more of a plain speak version of what that is. But Stewart, welcome.
Great, thank you for having me.
Yeah, so again, in plain speak, how would you define what Ondas does? What's the premise of the company?
Yeah, so we focus primarily on what we call mission-critical wireless applications, and today what we would call even going a little deeper, mission-critical IoT or Internet of Things applications. So as we're all getting more and more exposed to what we now refer to as Internet of Things, anywhere from your intelligent thermostat to intelligence in vehicles and the automated home. Where we have focused our attention on is network connectivity for industrial networks, and that would be for electric utilities, natural gas utilities, transportation, specifically with a focus on rail, and now industrial and commercial drones. And our company believes, and I think it's being proven out, that those networks are very different from consumer-grade wireless networks that we use for our daily lives, and they're networks that have not been upgraded yet, have not experienced the same wireless revolution that we all have on the consumer side, but are now set for a major upgrade, and that's where we've been focusing our attention for some time.
So when you say upgrade, I understand what mission critical is, but when you say upgrade, what's lacking in them right now, and what will the upgrade look like?
Well, what has happened in the industrial networks, and perhaps maybe your listeners are most familiar with what you see for first responders and utility companies, is that they have their own private radio systems, and those systems are typically installed in their vehicles, or they may be wearing a radio device, and those historically have been push-to-talk voice networks. And now what we are doing is been creating innovation for the data side as we experience various things, for example, artificial intelligence for consumer, the same types of automation are now occurring for industrial networks. The key issue for industrial networks is they've not had a reliable wireless platform to use as they approach their upgrade cycle. So what you'll see is they lag tremendously for types of connectivity that consumer folks are experiencing in their homes through Wi-Fi and through regular cellular networks. The same kind of automation needs to occur in industrial networks, but they have a different challenge. And that challenge is that the things they're automated or want to automate are dispersed over very large geographies and challenging locations, and they have a different data type requirement from consumer wireless.
And I guess they would have to have a lot of redundancies no matter how good the technology is, because they're mission critical, and if they're can't talk to each other or things go down, it can be catastrophic.
Right, and that's exactly right. So oftentimes they may look at multiple networks. For example, they may have a cellular network as a backup, but often what you'll see is they have the primacy or prime networks for them would be their own, a network they run themselves under their control. And part of the key component of a private network or private wireless network is not that they can't be exposed to vulnerabilities. There's the same weather patterns and hurricanes and natural and man-made disasters. The difference for them is they can put in aspects to the network that a consumer network can't rely upon. And in fact, we saw this very clearly recently in California with the wildfires. And what you almost saw here was a perfect storm of what is going to happen more increasingly and shows the vulnerability and importance of these networks. And I'll give you the example. When I don't know if all your listeners are familiar with what happened with the wildfire disasters the past summer, but one of the issues in how the utility companies were addressing this problem was by turning off the electric grid in areas that were exposed to wind and strong winds. And why was that? What has happened in the past is a tree will fall on a line, or a line will break due to a weather event. That will then, the line will drop, cause a spark, and then create a wildfire. And we've seen that happen over and over in California with the increasing amount of change in the climate and our cycles of drought and rain and vegetation. So one of the ways the utility was addressing it is just to turn the power off so the spark would not occur. Well, when you turn the power off, you start to have issues with the prime networks, the cable networks, and the cellular networks. They have limited amount of battery backup power in their infrastructure. And I'll use myself as an example. I was not in a fire danger area, and my power was not off, but the cable infrastructure was turned off for Comcast or Xfinity, and I lost my internet connectivity and also my home voice. And then the cellular network was under enormous stress because they were losing portions of their towers due to power cutoff. And so you ended up in this situation where the core networks for consumers were vulnerable, and they becoming increasingly vulnerable because they rely on electricity. So if you think about it, this is sort of the perfect storm for an industrial customer that's trying to manage its infrastructure, and even for the consumers, the network is going out, let alone having the ability for the industrial customer that's troubleshooting the network to rely on those consumer networks. So hopefully that was a long answer to sort of explain the complexities of some of these underlying networks and why it's important that industrial networks have their own networks.
Yeah, and you would get greater efficiency if you could fine-tune the action of a given network. It will turn off parts, turn on parts, monitor maybe weather and other conditions, integrate with other systems and see where, like you said, battery backup was going low, and turn on maybe for a short period of time in certain parts of the grid. I mean, a lot of efficiency and complexity that can be used if the network was robust.
Correct. In fact, the ironic thing about this is that even the technology we're talking about being implemented on the electric grid would allow them to isolate where those specific areas were occurring and then not have massive power outages, but isolate just in certain sections. In fact, there is a technology called Dropline technology where you could, in milliseconds, it takes about a second for a line to drop and hit the ground that would cause the spark. But there is the ability now for using communications throughout the grid where you could de-energize the line in milliseconds, a couple hundred milliseconds, and eliminate the potential for that spark to even occur. And so by investing in these types of technologies, you could even isolate and take a different approach to some of these problems that are persistent.
So what does the solution from Ondas look like? I know I'm sure part of it's proprietary, but is it just using existing technologies but layering them and connecting them, or is it a new type of technology that provides connectivity?
Well, we started out, the company started out developing a new type of technology for industrial customers, a new type of wireless technology that is different from the consumer wireless networks. It uses its own protocol, what we call an Airinterface protocol, and the idea behind it was to use licensed radio frequencies that are not used by the consumer networks with a very specific Airinterface protocol that maximizes the capacity of these licensed frequencies. So one of the important aspects of our technology is that unlike Wi-Fi and Bluetooth and many of the other consumer technologies, we use licensed radio frequencies. And there's some very strong advantages to using licensed frequencies. One is that they are exclusive use, and they're under the control of the company operating the frequencies. So it eliminates the concern for interference and allows these networks to cover much greater areas with less infrastructure. So when you approach building an industrial network that is not consumer focused, you have to keep the capital cost of that network down because it doesn't have the support of tens of thousands or millions of consumers paying a monthly bill. The idea behind using licensed radio frequencies is that they can transmit much greater range and with higher reliability than unlicensed wireless technologies like Wi-Fi. So our technology was developed around using licensed radio frequencies with an Airinterface protocol that's unique to industrial needs. One example of its uniqueness is that it allows for high capacity upstream data. So one of the things, as you probably are aware with a consumer network, is often what we're doing is we're pulling data down from the cloud. In industrial networks, the important information is at the edge inside the infrastructure, which goes everywhere. So it's not that a rail car or the electric grid needs to download a video from Netflix, but it needs to send back that critical data that's occurring at the edge, which can be a very remote or challenging location. So we designed our Airinterface protocol to carry a lot of upstream data versus downstream. And that's just one example of how the technology differs. We have also, when you mentioned proprietary, the technology initially started out as proprietary, but our customers, the utility companies and rail and now even drone, commercial industrial drone companies, have asked us to make the protocol available through a standards process. And so we have put the technology, the design, into a standards-based body within IEEE. So that means other companies can build to the same standard, growing the ecosystem for delivering products to the industrial customers.
Well, standardizing it may also open up opportunities for you guys to get to the highest levels of infrastructure. So I'm guessing probably the U.S. government, for instance, or other governments would want completely standardized, well-known and probably tested method of communication and reliability before they would implement anything, hopefully.
Well, it can vary. Actually, there's kind of a couple different sides to this. Some prefer the proprietary nature because then there isn't a recipe book there to unwind it in terms of interfere with it. So there are some disadvantages to making it a public standard. But on the other hand, you're able to add in security features from others. So I would agree with you that one of our challenges, and for any company our size, is to make sure that large industrial customers are comfortable adopting the technology, that they don't feel they're going to be isolated to the single company risk. So that was also an issue, which is they want to see a larger group of vendors or suppliers building to the technology. So what you see in the consumer area is you'll have multiple vendors producing the base stations, and then different vendors often producing the handsets. In the same case, we are focused on industrial customers, but with industrial companies that are looking to build to the standard.
So what are some of the KPIs that tell you, or what do the KPIs say when you've had a successful install and in-use project of your networks?
Well, for the companies, it depends on which industry we're focused on. So if you were to look at, let me give an example for drones, which is a nascent market. We're just now focused on that market, but you can, a KPI for them would be maintaining critical communications with the drone in a severe weather event. So one of the things that is holding back the implementation, I would say maybe the critical issue related to drone and the commercialization of them, drone delivery, is the vulnerability of the drone to communicate with the ground, and for the health of the drone to be the key data being transmitted at all times, so they're not in danger of an accident. So that's one of the key issues related to that market even being launched, and that's where our technology has come into focus for command and control of industrial and commercial drones. So that's a nascent market, just starting out, and that's an example of a market that's being held back right now for the lack of this type of technology. Then you have folks like the rail industry that want to move to things like automated train, and where they to improve efficiencies in the train network. And so that, in the case of train, it would be signals that weren't lost, accidents that have been reduced. One for trains is to run longer trains that are more efficient. And so this type of technology can allow for running trains closer together, so they are more efficient in the delivery and require less resources.
Is this going to be a tremendous boon, or do you think it's just an incremental improvement? Or I guess it depends on the industry, but is this going to be a radical change for some?
So all of these offer radical change, and to some extent, it really hasn't even gotten started. Specifically, if you take a look at the electric grid, we've been referring to something called the smart grid for many years. I don't know if you've heard that terminology, but that was really building intelligence in the grid. Effectively, what has happened is they've put in smart meters, but the balance of the grid, to a large extent, has not even started. And the projections of efficiencies are maybe 10 to 20% reduction in inefficient transmission of electricity, which, if you think about the challenges we're facing globally with climate change, that's a radical improvement. So then you might say, why aren't they doing that, right? Why aren't they embracing it faster and going faster? One of the critical things, for example, on the electric grid side, is that you need public policy to line up with those efficiencies. Today, electric utilities make their money by selling electricity. And if they deliver less electricity, they make less money. So if you take a look at companies that are delivering electricity, you will notice that we've already reached peak electricity to some extent in terms of generation. So generation is either flat or going down. So if you're an electric utility in this country, your revenues are decreasing, but your infrastructure is still all in place. So you have almost the same cost structure, but less revenue. What you need at the same time is policy to line up that says efficiencies are valuable for the electric grid. Those policies are not in place right now. I believe they will come into place and will lead to a transformation in the electric grid. What we do see, though, is on the rail side, where these are companies that are very focused on efficiencies and profit, that lines up nicely with all these innovations that are now available to them. So we see transformation in the transportation sector happening rapidly and based on these types of technologies. With electric utilities, we need the policy to be in place at the same time. We also see, yes, go ahead, sorry.
No, that's great. Those are great specific examples. Any other ones? I interrupted you, but.
Oh, on the security side, where we see a lot of embracing of the technology too, is efficiency and for security. So this would be for border and perimeter security. And for example, there's been a lot of attention focused on building physical walls, but with a lot of the sensor-based technology, for government usage, these type of industrial networks are very efficient for security type applications. So we see that as a growing area also.
Well, very good. Well, Stewart, what's the best way for listeners to find out more about Ondas and get in contact?
So the one of the easiest would be to go to our website at www.ondas.com, ONDAS. And one of the things to do is you could also follow some of our white papers on the site and also information we have on doing podcasts like this and articles related to the technology and where the industry is headed.
That's great. Well, Stewart, thanks for coming on. I appreciate it.
Sure. Thank you.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.